together really quick. All right, we have tangent of 3 pi over 8. It says use the half angle identity. In order to use a half angle identity, you need to have something over 2. It is currently not over 2. So we need to put this over 2. So we need something that says like tangent of something over 2. Now there's 2 tricks to doing this with a fraction. First way I think about it is because I'm dividing by 2, I'm going to first double this and then divide by 2. Because if I double something and then divide by 2, we have the same thing. So if I have $4 in my pocket, I multiply it by 2, I have 8, divided by 2, I'm back at 4. So you are actually just doubling this. If I multiply this by 2, the 2 will cancel out with this 8, and this 8 becomes a 4. So you are just going to have 3 pi over 4. That's why it works. How I sometimes do this is I'm just like, okay, a fraction over 2, I'm just going to divide this by 2. All right, in fraction world, that always works. But what you're thinking of is double and then divide by 2. So you should have 3 pi over 4. That should be the toughest part of these problems. Because now we can just go to our, let's see if I have these sheets on here. I do. Awesome. We're going to go to our half angle identities and find the ones that have tangent in them. That over 2 just says use this one, or use this one. There's a reason why this one's bolded. This is the one almost all the time you are going to use unless you're directed to use otherwise, like if you're proving an identity. If I'm just plugging numbers in, this is the easiest one. I don't have a giant square root I have to sort through. I also don't have a fraction with 1 plus a number on the bottom. This is almost all the time the easiest one to use if I'm just plugging in numbers. All right, so now we have tangent x over 2, and we're going to use this 1 minus cosine over sine. So we're going to say this equals 1 minus cosine. Now here's where you can make silly mistakes. It is just the 3 pi over 4. It is just what's in that numerator. And then that's over sine. Well, here's what's cool about anything that's over 4. Those are those half tick marks. Those are like pi over 4. Pi over 4 is square root of 2 over 2 for both of them. So both of these are going to be square root of 2 over 2. You just have to decide if it's positive or negative. Well, 3 pi over 4, that must be in quadrant 2 because our numerator is 1 less. If it was 5 pi over 4, it would be in quadrant 3 because it would be 1 more, if you remember that trick. So 3 pi over 4 must be in quadrant 2. All students, sine is positive, cosine is negative. So this will be a negative value. This will be a positive value. And so we're going to have 1 minus a negative square root of 2 over 2. All over and 3 pi over 4. Square root of 2 over 2. Here's where it's nice to be smart about things and not make your life harder than it has to be. Yeah, I can make this 2 over 2. Yeah, I can have this giant fraction on top and this fraction on bottom, and I can use keep, change, flip, do all that jazz. The smarter way to do this, or I find the easier way to do it, is just multiply your numerator and denominator by 2. Clear those fractions. Clear those fractions by multiplying by 2 over 2. And then make sure you distribute this 2 to both things. So that's going to equal 2. Well, a negative times a negative turns to a positive. Square root of 2 over 2 times 2 is just square root of 2. And that's over square root of 2. That's worth almost all of your points. All right, if you try to simplify this and you mess up, you still have 3.5 out of 4, depending on how bad you messed up. All right, I might give you a 4 out of 4 because you just did something, you just forgot a negative sign or something. But to simplify this, we have to multiply the bottom by square root of 2, which means I have to multiply the top by square root of 2. Once again, don't forget to distribute. I'm going to run out of room, so I'm going to clear this space for me. Oh, that's nice. That's going to equal 2 square root of 2 plus 2 all over 2. People on test lost their minds by this fraction. To simplify this, you have to break it into 2 fractions. 2 square root of 2 over 2 plus 2 over 2. It breaks into 2 fractions. You can't cancel out like that. You can't cancel out like that. Nothing's going to cancel out. You are just turning it into 2 fractions. So that's just going to equal square root of 2 plus 1, which was D. I think like 6 of you got that. Questions on that? All right, questions on the homework? Leo.
21.
Ooh, I don't even have the homework. There we go. Just so I can see what 21 is. 21 is asking me, all it's asking for is what quadrant are you in? What quadrant is that in? Realistically, that's all it's asking. Let's see if I have a picture of it. I don't. That's okay. I'll just take a picture. So this harkens back to the days where I'm just basically asking you, what quadrant is this in? And is tangent positive or negative in that quadrant? So all we have to know is it going to be positive or is it going to be negative? That's all they're asking. So I really don't even care what this says over here. They're saying at negative 5 pi over 12 is tangent positive or negative. So if it's in quadrant 1, it's positive. Quadrant 2, negative, negative. Finally, in quadrant 4, it would be positive. That's all it's asking. Or quadrant 4 would be negative. I'm sorry. All students take. Well, first of all, it's negative 5 pi over 12, so I'm going to add 2 pi to it so it's positive. Sometimes it's easier if it's positive, which equaled 19 pi over 12. If you put that in degrees, you'd see it's in quadrant 4. Or another technique you can use, rather than putting in degrees, just do 19 divided by 12. Figure out what the decimal is. Because 2 pi would be here, so a 2 would be right here. And then you can find your decimals along there to figure out which quadrant it's in. But it is in quadrant 4, where tangent is negative. All right? Yeah? I would add the 2 pi so I wasn't dealing with a negative angle. Because a negative means you have to go the opposite direction, which means you have to rethink your unit circle in the negative direction. So you have to redraw everything. You'd have to picture, negative pi over 2 is now on the bottom. Negative pi is over here. 3 pi over 2 would be up here negative. So I just make it positive because we're used to going in the positive direction. Does that make sense? If you can picture, if you know where negative 5 pi over 12 is, what quadrant it is, you don't have to make it positive. If you can just go, oh, that's quadrant 4 because it's just that little bit down here, then you're good. Okay? Other questions? Yeah, Mary.
27.
Specific question?
Well, I was just confused about like the denominator.
Oh, how it just disappeared?
Yeah.
Well, just a quick reminder. Well, let's go back here. Don't I have it? I don't have it. When we're dealing with double angle formulas, that's what they're asking here. They're actually giving us one side of a double angle formula. So we'll just put our double angles right next to it. So they give us 2 tangent of 15 degrees all over 1 minus tangent squared of 15 degrees. See how it matches up with the x's here? So I can go one step backwards and just replace this x with 15 degrees. And then it'll just be tangent of 2 times 15 degrees. So if you can go this direction, you can definitely go backwards once you figure out what that x is. All right? Gracie?
Oh, that was my question.
Oh, did I answer your question?
Yeah.
Cool. 2 birds, 1 stone. Other questions? Yeah. 13. So we have tangent of 15 degrees. We're supposed to use half angles, correct? So we need to turn that 15 into something over 2. Well, the easy way to turn something over 2 is to double it and then divide by 2. So double your 15 gives you 30. Divided by 2 is still 15 degrees. 30 divided by 2. Now we're using 30 degrees. Well, tangent of half angle, we have 3 different possibilities to use it. I just picked this one, probably the harder of the 3, one of the harder ones. You could have picked any one of them, it would have worked the same. But I just picked this one. I said sine of 30 degrees, 1 plus cosine of 30 degrees, which led me to here. That's why I made a terrible choice. See how I have to multiply by the conjugate? If I would have picked, I gotta stop going back and forth between these. If I would have picked this one, I wouldn't have to worry about the conjugate. You would have been done in like 3 steps. You just would have said, well, this is sine of 30 degrees, cosine of 30 degrees. It would have been real quick. But because of the method I picked, I ended up with sine of 30 is 1/2 is the square root of 3 over 2. To clear the fractions, I multiplied the top and bottom by 2, and then I had to multiply by a conjugate. But if I would have flipped it and used the other one, it would have been done probably right here. Because I just would have multiplied by a square root. I wouldn't have multiplied anything. I'd be done. All right, so that probably isn't the best way to do it. The other one that's bold would be a much better one to choose. All right, other questions? Okay, so I was talking about the test particularly because this section gets hard if you don't practice it and you don't know what I'm talking about because it keeps building on itself. All right, so if you're one of those people that are just going through the motions and doing your answer keys, you're going to get lost really quick. And that test we just took is going to seem like a piece of cake compared to this one. Those of you that stay on top of this, keep up with your homeworks, learn it, it'll be the same test as we had last time. Just as easy or hard, depending on how you viewed it, I guess. But it won't be any more difficult than the last one. But those of you that are just doing your homework, we just keep building, guys. All right, so we're going to use the identities to find sine and cosine. So we're going back to the same idea that we've been using over and over and over, where I give you something, and you have to give me other identities because of that. In this case, I'm giving you a double angle. I'm giving you sine of 2 alpha equals negative 8 over 17, and 2 alphas between 180 and 270. Well, 180 and 270 is going to be quadrant 3. Here is something we need to do, though. So whenever I talk about 2 alpha, it's in quadrant 3. If I ever talk about alpha, it won't necessarily be in quadrant 3 because this doesn't specifically say what quadrant alpha is in. But it's not hard to figure it out because if I have 2 alpha, if I just divide that by 2, I have alpha left. So what you're going to do is you're going to divide this entire thing by 2. So I'm going to divide this entire thing by 2. And that's going to give me 90 is less than alpha is less than 135. So that means anytime I'm talking about alpha, I'm in quadrant 2. So if I were to say something like cosine of 2 alpha, I'm talking quadrant 3. If I say cosine of alpha, I'm in quadrant 2. All right? Really, the only time you care about it is when you get down to your final answers. Then you check to see if it should be positive or negative. All right. Here's where this can get confusing. I need to break this down, this sine of 2 alpha, so I can get sine alpha and cosine alpha out. What you're going to do now is you're going to look at your double angle formulas and see which one's going to help you. All right, here are all my double angle formulas. Well, right now we know sine of 2x, so I could plug that value in here. So let's hypothetically think about that. So my sine of 2 alpha equals negative 8 over 17. So I could replace that with negative 8 over 17. However, I have sine x and cosine x both there, and I don't know either of the values. So I can't actually solve for one of those. So that isn't going to work. If I would do the same thing for cosine of 2 alphas. So in this case, I don't know that value. But if I did know this value, I could reduce it down to cosine of just 1x and just sine of 1x. I want to get those alone so I can solve for them. This is why anytime you have a problem where you're dealing with a double angle that you always have to know cosine of 2 alpha. You always have to know it. So this first step is actually to find cosine of 2 alpha. If you're already given cosine of 2 alpha, you can skip this step. So you can skip this step if you already know it, but whenever you're doing double angles, you have to know what cosine 2 alpha is. In order to get cosine 2 alpha, we are just going to simply use the fact that cosine of x equals the square root of 1 minus sine squared x. That comes from sine squared plus cosine squared equals 1. It's just readjusted. Now what we're going to do is we are going to let x can be anything I want it to be. So I'm going to let x equal to alpha to match our problem. So instead of cosine x, we're going to have cosine 2 alpha is going to equal the square root of 1 minus sine squared 2 alpha. I know what cosine 2 alpha is. So that means this whole thing equals the square root of 1 minus that negative 8 over 17 squared. All right, now working this out, is that 289? Do I even have this? All right, so that's going to be, 289. So that's just going to equal the square root of 289 over 289 minus negative 8 squared is 64 over 289. Remember, at this time, we have plus and minuses out front. I always forget those, but we should have plus and minuses out front because we don't know which it is yet. Let's finish this up over here. That's going to equal plus or minus the square root of 225 over 289. Well, the square root of 225 is 15. Square root of 289 is 17. So we're going to have that cosine of 2 alpha equals 15 over 17. Now I'm going to look here and say that's 2 alpha. 2 alpha is in quadrant 3. All students take tangents positive, so cosine must be negative because we are in quadrant 3. That's not my sine alpha, that's not my cosine alpha, but is the key to get to both of those. All right, so once again, every time we have 2 alpha, you have to find cosine 2 alpha first. You have to find it first. The next thing we're going to do is we're going to find cosine alpha. The next thing we're going to do is find cosine alpha. So that is my next step, is to find cosine alpha. And we can find cosine alpha because if you look at your identity sheet, cosine of 2 alpha equals 2 times cosine squared plane alpha minus 1. That means if I solve for this, I'll know what cosine alpha equals. Well, we know what cosine 2 alpha equals from right above. Right above there, equaled that negative 15 over 17. So that's what we're going to replace. We're going to replace cosine 2 alpha with that negative 15 over 17 that we got from above. And that's going to equal 2 cosine squared alpha minus 1. Now it's just algebra. Add 1 to both sides. Remember, 1 is really 17 over 17, so I can combine it right away. So we'll have 17 over 17 minus 15 over 17 equals 2 cosine squared alpha. 17 minus 15 is 2 over 17 equals 2 cosine squared alpha. If you're someone that struggles dividing fractions, we do have to divide 2 from both sides, but you could think about that as just multiplying by 1/2. I noticed a lot of us made little mistakes like that on the test where we didn't quite divide stuff. So if you struggle with dividing, just think about you're multiplying both sides by 1/2. That can make it easier to see that we actually have 2 over 34 equals cosine squared alpha. All right, now we just have to take the square root of both sides. So we're going to have cosine alpha equals plus or minus the square root of 2 over 34. Well, we could simplify that. That'll be plus or minus the square root of 1 over 17. I guess I'll go through all the steps because the class kind of struggled with it. That's plus or minus the square root of 1 over square root of 17. So our cosine alpha equals, multiply the top and bottom by square root of 17, you'll have square root of 17 over 17. Now I just have to decide if it's positive or negative. Well, I'm talking about alpha, not 2 alpha, I'm talking about alpha. So that's when you go to your alpha one. We said alpha was in quadrant 2. Cosine is negative in quadrant 2, so our cosine alpha equals negative square root of 17 over 7. All right, we have 2 ways to solve for sine. We have 2 ways we can solve for sine. Either we can use this formula where cosine 2x equals 1 minus 2 sine squared x, or we can just go back to sine squared plus cosine squared equals 1. And that's the method I'm going to use because that's the method most people are most comfortable with. So I am just going to use the fact that sine squared x plus cosine squared x equals 1, which reduces down to sine x equals 1 minus cosine squared x. Well, in this case, we know our cosine value. So we're going to have sine, and we actually have alpha, so I'll change it to alpha, equals the square root of 1 minus, you can be smart about this or you can make your life difficult. I get that cosine alpha equals negative square root of 17 over 17, so a lot of us are going to plug that in. It'd be much easier to plug this one in. They're all equal to cosine alpha, so I can plug this one in, I can plug this one in, I can plug this one in. This is the easiest one because it's just 1 over square root of 17. So that's the one I'm going to plug in. So we're going to say minus a negative 1 over square root of 17 squared. These are all plus and minuses. So we plus and minus the square root of 1 minus, actually I'm going to change that to 17 over 17 just to save me a step. minus 1 squared is just 1. Square root of 17 is just 17. Continue up here. We are going to have plus or minus. The square root of 17 minus 1 is 16 over 17, which is going to equal plus or minus 4 over the square root of 17. So that means our sine alpha is going to equal plus or minus, we'll take care of that in a second, but 4 square root of 17 over 17. And we said when we were talking about alpha, we are in quadrant, let's go back to it. 2 alphas in quadrant 3, alpha's in quadrant 2, sine is positive in quadrant 2, so this is just positive. Yes, it took me a long time to go through this problem. Yes, it might take you the first couple times you do this a long time to go through this problem. But the better you get at it, the easier they are and the faster they are to do. Once again, if you're one of those people that just copy the answer guide, this will never be easy and will always take you a long, long time. Yeah?
In the second part of the problem we did, the last part, we got the answer for what cosine squared was, like up at the top. Could we just have plugged that in as well?
Yes, you could have plugged that in as well. Yep. Yep. Anytime that you have, that's a really good thing to point out, that if you have cosine squared equals something, you can just plug that right into your sine squared and it can save you a bunch of time. I didn't want to do that because it confuses people sometimes. But yes, if you see something that equals something over there, you can always plug it in. All right, questions on that? Guys, this just takes practice. It's plugging and chugging, knowing where things have to go and what formulas to use. And you have all the formulas at your hand. You don't need to memorize them. Gracie?
How do you know to use sine squared x plus cosine squared x?
Because I knew cosine alpha. Anytime you use cosine alpha, I can use anything that we need to know that value for. So I could use this one and plug it in here. But like I said, we also know cosine 2 alpha, right? So I could have taken that negative 15 over 17 and plugged it in for this one and solved for sine also. Okay. I'm just looking for values that I know and identities that I know where I can plug it in. It really is just that. I know an identity that has cosine in it. Let's use that to get to sine. Does that kind of answer your question? All right. Generally speaking, if I have sine or cosine alone, I'll always use sine squared plus cosine squared to want to get the other one, just to keep it consistent. All right, now we're going to get into verifying identities, which can get really tricky. I think they're easier, but they involve more forethought. You have to think about what's going to result if you do something. All right, so we have sine of 3x equals sine x times 3 cosine squared x minus sine squared x. All right, we're going to focus on that sine cubed x. Problem is we don't have a triple angle identity. We only have a double angle identity. This would only work if it said 2x. Then I have an identity. Well, we can break it apart. We can break this apart into something that we can manage, and that is 2x plus x. Because now I can use my angle addition property. If that's my alpha and that's my beta, for sine of an angle plus an angle, it's just sine times cosine plus cosine times sine. So we're going to break it apart using our angle addition. So that is sine of our alpha times our cosine of our beta. Our alpha is 2x, our beta is x. And that'll be plus cosine of our first angle, which is 2x, times sine of my second angle, which is x. Here's why these can look complicated, because it's going to get really, really big, really, really fast, and then it'll get small. Sine of 2x, we have a double angle formula you will have provided for you on the test, so I'm just going to rewrite this as 2 sine x cosine x. So I'm replacing all of that with this. Now we're also multiplying that by that cosine. that was still on the outside. Here's where we have a small problem. Look at your double angles for cosines. You have 3 of them, and only one of them is going to work. Only one of them is going to work. So you have to look at the right-hand side. And my advice to you is on that right-hand side is actually work it out so you can see what numbers you have. So I'm going to go ahead and do this. I'm going to work out that right-hand side. I'm going to distribute that sign to give us 3 cosine squared x sine x minus sine squared x. Now you have to have forethought. This cosine 2x, we can either write it as two cosine squared x minus 1, or we can write it as 1 minus 2 sine squared x, or we can write it as cosine squared minus sine squared. My question is always, do we have any just 2 sine squareds or 2 cosine squareds on this side? Do you see anything that says 2 sine squared or 2 cosine squared on this side? If you don't see one of those, you're more than likely just going to use that cosine squared minus sine squared, because otherwise you're creating just these rogue 2 sine squareds or 2 cosine squared. We don't have those, and we do have plenty of sine squareds and cosine squareds, so a good idea is to just try turning that into our cosine squared x minus sine squared x. And don't forget about that sine x that's on the outside. Well, 2 sine x cosine x times cosine x is equal cosine squared. And I'm just going to follow the order that they have on the right-hand side. So I'm going to change this to 2 cosine squared x sine x. Now we're going to distribute that sine x to everything. So we're going to have plus cosine squared sine x minus sine x squared times sine x is going to be sine cubed x. Right now is when you know if you did it right or wrong. If you pick the wrong one, this isn't going to look anything like that right-hand side, but you can see it's already looking like that right-hand side. I have that negative sine cubed that we have. I also have 2 cosine squared sine x. Well, this is cosine squared times x, so if I have 2 of them here and 1 of them there, I have a total of 3 of them. So we're going to have 3 cosine squared sine x minus sine cubed x, which equals the other side, and we are good. Right.
You answered my question. I was just going to ask if it was a cube sign or a square.
Oh, it's a cube. Are you seeing my penmanship's bad? Is that what you're saying? That would hurt my feelings so much. I've never been told that before in my life. These aren't easy because a lot of you will just quit. It's not going to work the first time and you're just going to quit. You have to keep trying. If this didn't work, I would just pick one of the other 2 and see if it works. You almost automatically know on the other side. So what can help you on these is maybe do it on scratch paper first. So you're not constantly erasing and stuff. Just take a piece of scratch paper, see if it works. If it does, copy it down. If it doesn't, then you don't have to erase a billion, million, trillion times. All right, we're just going to start the next one. It was just in case we had time, because it's kind of a good problem. It is tangent of x over 2 plus cotangent of x over 2 equals cosecant x. The whole premise of this is to look at the right-hand side to know how to write your tangent values. So really quick, if you look at your half-angle identities, you're going to see that there's 3 different ways to write your tangent values. Well, note that we have tangent of x over 2 plus Well, this is really just 1 over tangent of x over 2. So you can rewrite those tangents in any one of these 3 forms. But the first thing you're going to look at is, are there any square roots on your right-hand side? No. So I'm probably not going to use this one. Is there a sign on the other side? Yeah, there's a sign there. Because you can rewrite this as 2 times 1 over sine x. Not only is there a sign there, that sign is on the bottom. Which means when I rewrite this tangent of x over 2, I'd want sine to be on the bottom. So I would just look at my things and ask myself which one has sine on the bottom. And that's that one. I'm going to rewrite my tangent of x over 2 as 1 minus cosine over sine. So our first one is 1 minus cosine x over sine. I want sine on the bottom of this one as well. The problem is this is 1 over something, so that means it's going to be a reciprocal. Like 1 over 3 over 2 actually equals 2 over 3. So I have to think in reverse. I actually want the sign on top here, so that when I take the reciprocal, it will be on the bottom. So you're going to go to your tangents and see, oh, this one has sine on top. So I'm going to pick that one as sine over 1 plus cosine. So we're going to have 1 over sine over 1 plus cosine x. Well, now rewriting this, we're going to have 1 minus cosine x over sine plus 1 plus cosine x over sine, since it is a reciprocal. Note your cosines will cancel out, and you'll be left with 2 over sine x, which is equal to that. Super easy problem if you pick the right one. If you pick the wrong one, you will not be able to solve it. So these are really just look at the right-hand side to tell you what to do. You got 3 paths to go down. There's only one that works. All right, any questions for me? Test scores online. You'll get your test back tomorrow. I'm thinking test corrections will be due next Friday, maybe even the Monday after, because I know a bunch of people are missing tomorrow for various things, I think, in my other class. All right.